Hi guys, in this series of videos we'll be looking at the International University of Management course called Quantitative Methods 1 for first year students. We'll be discussing concepts and doing examples along the way, just following the course outline and the manual as stated here. Okay, so let's just jump right into it right at the start. We'll just do lesson 1, and for lesson 1 this video will be a short one probably, and we'll just be looking at these definitions. What are these things? In case we see some of these terms coming up later on, so we know exactly what we're dealing with. Now I'm assuming I won't be teaching anything new to most of you, but if you're doing this course and you haven't been in school in a while, maybe it'll be good just to check a bit of a recap. Okay, so let's jump right in with the first one, number theory. What different types of numbers do we get? Okay, so I think the best way to approach this would be to do this. Let's draw sort of a bit of a diagram. Let's say those numbers, that'll represent our natural numbers. Okay, for natural numbers, we'll just draw right an N. Oh, that's a bit too ugly. Let's redo that. Okay, so let's do that. That'll be natural numbers. Now, what are natural numbers? Natural numbers are all numbers from 1, 2, 3, 4, etc. Right, so normal counting numbers. That's another way of saying it. And we can say whole numbers, which is pretty much the same thing. Whole numbers are just natural numbers plus 0. So whole numbers are just 0, 1, 2, 3, 4, etc. Okay, so whole numbers, natural numbers, we can pretty much assume they're the same thing, except whole numbers gets an added 0. Now, all whole numbers and natural numbers are also part of the next set of numbers, which are called integers. So let's do integers in green. So we see integers include all the natural numbers. So for integers, that has the symbol Z, and so that is the same as all the natural numbers or whole numbers, but it includes all the negatives, right? -2, -3, etc. So these are all the integers, all positive and negative whole numbers. Right, and now again, this is all part of the next set. Now the next set, what color should we do? Let's do pink for that one. So the next set of values, types of numbers, are the rational numbers. Again, rational numbers, we usually write a Q. So we have a Q. Those are all the rational numbers. Now what is a rational number? So a rational number is any number that you can write as a fraction. Any number that you can write as A over B if both A and B, if both of them are integers. So an integer divided by an integer is a rational number. Something like 3 over 5, right? That's a rational number. Something like pi, on the other hand, that's not rational because you cannot write pi as a fraction. We can approximate it by saying 22 over 7, but let's maybe do this on a calculator. If we do 22 divided by 7, we get that value here. Let's copy and paste that one just to show. So that's what pi is, right? Well, that's what 22 over 7 is. Let's rather say that. Now, what happens if we just type pi? Pi. So we can see there's a bit of a difference, right? So 22 over 7 that's just an approximation of pi, it's not really pi. So we can see here it already diverges pretty soon, already at the 1, 2, 3, third decimal place, it's already different. So this is an approximation, but not pi. So in essence we can say this is a rational number, but this is not a rational number, right? Big difference. Okay, so rational numbers, just to recap, anything you can write as an integer divided by an integer. That is a rational number. Another way of thinking about it is 3 over 5, we can write that as 0.6. Right, so 0.6 is rational because it doesn't continue forever with its decimal expansion. Right? And if a number does continue forever with its decimal expansion, then it's irrational, unless there's a pattern. Something like 0.12, 12, 12, so that just keeps on repeating 1, 2 forever. That will be rational. Why? Because we can write that as a fraction. Right? We can write that as a fraction. Let's do a simple one, an easy one. If we say 0.333, so that keeps on going forever. It never stops, but it has a pattern, right? It's 3, 3, 3. You know what's coming next all the time. So this we can write as a fraction as 1 over 3, or 3 over 9. Or any of those things. So this is a rational number. Okay, enough talk about irrational numbers. I think you have the idea. What is the next thing we look at? Well, that would be irrational numbers. Irrational numbers. Okay, so let's, that looks like they overlap a little bit, which they shouldn't. Let's draw that over there. That'll be irrational numbers. And for that, we just say it's the complement of the rational numbers, right? So Q with a little apostrophe. So it just means not Q, not rational. So if something is not rational, then it's irrational, if it is real. So pretty much that's the most important thing here. So in essence, pi, that's an example of an irrational number, because that's 3.1415926, etc. Right? It just keeps going. And this is already rounded off because it should be 5, 3, 5, and continue like that. So that's irrational. The value e is irrational. I think that should be on here as well. Let's just check. Where's e? There's an e. Right? So that'll keep on going. It looks almost like it repeats, but it doesn't really. Go type that in your calculator and you'll see it doesn't really repeat. Or type it in a search engine like Google and see what answer you get. The decimal expansion never stops and it doesn't have a pattern. That's also irrational. So we've got some interesting constants which are irrational, but then we also have things like the square root of 2, which is irrational, or the square root of 3, that's also irrational. Square root of 4, that's not irrational, right? The square root of 4 is equal to 2. And what do we know about 2? 2 is, like we saw here, that's a natural number, so it's also a whole number, which means it's also an integer. And any integer like 2, we can write that as 2 over 1, or 4 over 2, or 6 over 3. So we know it is a rational number. But anything else, anything that doesn't give you a nice perfect answer as a square root or a cube root or a fourth root, that will be an irrational number. So if you have square root of 5 and you don't get a nice integer as an answer, then you know it's irrational. Okay, so pretty much everything that is some specific constants that you know, like pi or e, or the root of any number that doesn't give you an integer, those are irrational. All right, and then the next level we get is the real numbers, and I think that's where we'll stop for today, at the real numbers. I don't think we need to know anything more than the real numbers. Okay, so real numbers are just all numbers that are either rational or irrational. Those are real numbers, right? So pi is a real number even though it's irrational. 2 is a real number, and this is rational. It's an integer, it's a natural number, it's a whole number. So any number that we can think of is real, except for something like this. What about the square root of -1? Well, if we type square root of -1, we should get an error on our calculator. Let's see what this gives us. Square root of -1. Oh, it actually gives the correct answer. It's I, which stands for imaginary. That's an imaginary part of a complex number. But we don't need to go into complex numbers for now. Suffice it to say that they are not real, but they are very useful in the real world. Engineers use the square root of -1 or any other negative number to build the bridges and houses you live in and walk over. So they are important. Okay, that was just a recap of what you probably learned in grade 9 or 8 or 7 or something, and hopefully that just jogged your memory a little bit. Okay, let's get into the rest, which will be a little bit quicker. Okay, a fraction. So we already talked about fractions a little bit. Let's use the fraction 59 over 250. Oopsie. I'm just going to write that a little bit bigger. 59 over 250. Okay, so that's a fraction because it's an integer divided by an integer, right? That's a fraction. A decimal, what is a decimal? Well, you know what a decimal is. So if to write this as a decimal, all we do is we type that in the calculator, and let's see what that gives us. 59 divided by 250, 0.236. 0.236. So that's a decimal. What is standard form? The standard form, you might have forgotten a little bit what that's about. So standard form, we have a number that's not 0, then we have a comma, and then we have the rest of the number until we start getting zeros, like here, right? Then we say times 10, and we just say how far did we move the comma from the original. So in this case, we moved the comma to that spot. Well, let's actually look at it from this side. So from here, how do we need to move the comma in order to get our actual answer? Well, we need to move it 1 to the left, right? If we move the comma 1 to the left, we'll have our original answer. So that means to the left means we put in negative there. Move it left 1 spot. That's standard form. Right, maybe let's just do one more example of standard form. Let's say we had 345.67. If we want to write that in standard form, we say have one number that's not 0, then the comma, and then the rest of the numbers. In this case, 4567 times 10. And from here, what do we have to move the comma? We have to move it 2 to the right, right? If we move it 2 to the right, we have original value. So it's 2 to the right, so positive 2. Okay, that's standard form. Significant numbers. So significant numbers are numbers that actually make a difference to your answer. And what we can say is leading zeros, or zeros at the front of a number, they don't count as significant. Even if you think they might be, they don't count as significant. So if we look at the value 2, right? 2 is a significant number, it tells you something about the value. What about the value 02? Let me just write that here. 02. How much is that? Well, that's still just 2, right? So this 0 is insignificant. It doesn't add anything. It doesn't change the value. It doesn't matter how many zeros you put in front. It doesn't change the value. So that's the idea about significant figures, significant numbers. Percentages? Well, let's do this again. If we do 59 out of 250, what percent is that? Okay, so we can say that will be, to calculate that, we'll say 259 over 250 times 100 over 1 plus percent. So centi is from the Latin for 100. So percent is out of 100. So we just do 59 over 250 times 100. And what do we get? We should get this, right? Because that is already 59 divided by 250. And then we just times it by 100. We get 23.6%. 23.6%. Okay, so that is a percentage. A ratio. So we can do the same thing here. This could mean something like, for every 59, the ratio of, let's say, of kilometers or liters to kilometers in your car. So you get 59 liters to 250 kilometers. For a rate, you can say the same thing. You can say you get 59 liters per 250 kilometers. And proportion is pretty much the same. These three things, no real difference in what they mean. These are just nuanced differences. Okay, so I know this was a bit of a rambling video, but hopefully it just gave us a bit of a callback to what we learned in school, different types of numbers, just so we know as the course progresses what each of these terms mean when we see them in the questions. If you have any questions about how any of these things work, maybe like how do we know if something is rational, irrational, any of those things, please ask them in the comment section below. Or if you've got a different way that you'd like to explain any of these terms, please feel free to add them and let's start a discussion in the comment thread. Thank you, and we'll be back shortly with lesson 2.